we are detecting a rhythmic stutter in the planetary engine, a signal that suggests the magnetic heartbeat of our world is skipping a beat. New data from the Swarm satellite constellation has just confirmed a disturbing acceleration in the weakening of Earth's magnetic field, specifically over the South Atlantic Ocean. For decades, we have watched this anomaly grow, a deepening dent in our protective shield, where radiation from space dips dangerously close to the surface. But until this very moment, we looked upward for the cause, analyzing solar winds and atmospheric density. We were looking in the wrong direction. The cause of this distortion is not coming from the stars, but from deep beneath our feet. We have now correlated this magnetic breach with a colossal physical obstruction located at the boundary between the mantle and the core, a structure so massive it defies conventional geological explanation. We are looking at evidence that the machinery generating our magnetic field is being physically obstructed by something ancient, something heavy, and something that is actively fighting the flow of molten iron responsible for keeping us alive. This is not a theoretical model. This is a direct observation of a planetary interaction that has likely been unfolding for millions of years, but is only now entering a critical phase of volatility. As we analyze the latest geomagnetic jerk, a sudden, sharp change in the field's acceleration, we are forced to confront a reality that geophysics has hesitated to fully embrace. The core is not spinning in isolation. It is being manipulated. To understand why our shields are failing in specific sectors, we have to peel back the crust and look at the most mysterious frontier in science, the Core-Mantle Boundary. Before we descend 2,900 kilometers down, consider the immediate implications of the data on your screen. The South Atlantic Anomaly is often referred to as a pothole in space, a region where the magnetic intensity is significantly lower than the global average. Satellites passing through this zone are bombarded by high-energy protons because the shield is too weak to deflect them. We used to think this was a random fluctuation, a chaotic feature of the fluid dynamics inside the Earth. However, the new mapping reveals that this weak spot is not drifting aimlessly. It is anchored. It is hovering directly above a specific geographic footprint in the deep interior. This correlation changes everything. It suggests that the magnetic field is not just generated by the core, it is being sculpted by the mantle. If you want to stay ahead of these planetary shifts and understand the data that defines our survival, make sure you are subscribed to the channel, as we will be tracking these geomagnetic updates in real time. Now let's look at the seismic tomography data that solves the first half of this puzzle. To see inside the Earth, we cannot use light. We must use sound. When a massive earthquake strikes, it sends shock waves ringing through the planet like a bell. By measuring how fast these waves travel to seismometers on the opposite side of the world, we can build a three-dimensional map of the interior. Sound travels faster through cold, dense rock and slower through hot, less dense material. For years, the global map of the deep Earth appeared relatively uniform, a smooth transition from the rocky mantle to the metallic core. But as our sensor networks became more sensitive, a startling picture emerged. The deep Earth is not smooth. It is dominated by two colossal provinces of slow-moving waves. In the scientific literature, These are called large low-shear velocity provinces. That is the technical term. In reality, they are mountains. But calling them mountains does not do them justice. These are superheated, chemically distinct blobs of rock that are 100 times taller than Mount Everest. There are two of them. One is located beneath the Pacific Ocean, sprawling across a massive area. The other, and the one most critical to our current magnetic crisis, is located directly beneath the African continent. Together, they cover roughly 30% of the Core-Mantle Boundary. We are talking about structures the size of continents, buried halfway to the center of the Earth. The discovery of these giants was a shock, but the realization of what they are doing to the core is the true revelation. The outer core, the ocean of molten iron and nickel that swirls around the solid inner core, is the dynamo that generates our magnetic field. For this dynamo to work, the iron needs to move. It needs to swirl in complex convection currents, driven by the release of heat as the core cools down. This movement creates electrical currents, which in turn generate the magnetic field that stretches out into space. Here is the problem. The efficiency of this engine depends on heat escaping from the core into the mantle. If the heat cannot escape, the iron stops churning. The two massive blobs, the one under Africa and the one under the Pacific, behave differently than the rest of the mantle. The data indicates they are much denser and much hotter than the surrounding rock. They act as thermal blankets. They are insulators. Because they sit heavily on top of the outer core, they trap the heat inside. Imagine a pot of boiling water. If you place a heavy, insulated lid over one section of the water, the boiling action in that specific area changes. The bubbling slows down. The flow becomes turbulent and erratic. This is exactly what is happening to the iron currents beneath Africa. The African blob is stifling the flow of heat, causing the molten iron beneath it to become sluggish. This disruption in the flow of iron creates a disturbance in the generation of the magnetic field. The magnetic field lines that should be strong and organized in this region become twisted and weak. This is the direct link we have been searching for. The South Atlantic anomaly, that dangerous weak spot in our shield, sits almost directly above the edge of the African blob. We are seeing a cause and effect relationship on a planetary scale. The giant lurking in the mantle is sabotaging the dynamo in the core. However, the plot thickens when we look at the composition of these blobs. Initial assumptions were that these were simply upwellings of hot mantle rock, like the wax in a lava lamp waiting to rise. But the shear wave velocity data tells a different story. If they were just hot rock, the waves would slow down. Yes, but the density calculations derived from Earth's gravity field suggest these structures are incredibly dense. Hot rock should be less dense and rise. These structures are hot, yet they are heavy enough to stay sunk at the bottom of the mantle. They are stable. They are ancient. This density paradox is the first major clue that we are not dealing with normal geological formations. These are not merely thermal plumes. They are chemically distinct piles of material that have remained separate from the rest of the mantle for potentially 4.5 billion years. They are foreign objects in our own planet. Let us look closer at the edges of these structures. The seismic boundaries are razor sharp. When seismic waves hit the edge of the African blob, they do not transition gradually. They reflect and refract as if hitting a solid wall. This indicates a dramatic change in material composition. On one side, you have the standard silicate mantle of the Earth. On the other side, inside the blob, you have a material that is rich in iron, extremely dense, and conducting heat in a completely different way. This sharp boundary is where the magnetic interference is most violent. The fluid dynamic simulations of the outer core show that as the molten iron rushes past the root of these blobs, it gets deflected. It creates eddies and reverse fluxes. A reverse flux is exactly what it sounds like, a patch of magnetic field that points in the opposite direction to the rest of the planet. When we look at the magnetic map of the Earth, we see these patches of reverse flux growing beneath the South Atlantic. They cancel out the main field, creating the weak spot. The African blob is essentially acting as a brake, a massive physical obstacle that creates turbulence in the fluid core. This turbulence is eating away at the integrity of our shield. But here is the detail that keeps geophysicists awake at night. The blobs are not static. While they are stable over geological timescales, the edges are dynamic. We are detecting ultra-low velocity zones at the very base of these blobs, thin layers where seismic waves almost grind to a halt. This suggests partial melting. The blobs are interacting with the core. They are exchanging material. Iron from the core may be leaking up into the blobs, or pieces of the blobs may be dripping down into the core. This exchange of material complicates the magnetic picture even further. If conductive iron is seeping into the rocky mantle structures, it changes their electrical conductivity. It turns the blobs into semiconductors, which means they can interact with the magnetic field electromagnetically, not just thermally. They could be pulling on the field lines, stretching them, twisting them. The question we must ask is why these structures exist at all. If the Earth was once a molten ball of magma that differentiated into layers, core, mantle, crust, everything should be relatively homogenized by density. Heavy stuff sinks, light stuff floats. These blobs violate that smooth sorting. They are clumps of heavy material that have refused to mix with the rest of the mantle for the entire history of the Earth. This points to a disturbing possibility. They are not part of the natural cooling process of the Earth. They are remnants. They are leftovers. The sheer volume of material, millions of cubic kilometers of rock, suggests an origin event of cataclysmic proportions. We have established that the magnetic field is failing because of the African blob. We have established that the African blob is a dense, chemically distinct pile of alien material sitting on the core. But as we feed the density and volume data into our planetary formation models, a single terrified conclusion begins to emerge. The numbers do not match a standard Earth composition. The isotopic signatures we are beginning to infer from deep source lava plumes, volcanoes like Hawaii and Iceland that are thought to feed off these blobs, show ratios of noble gases that date back to the very birth of the solar system. We are looking at a graveyard. The African and Pacific blobs are not just rocks. They are likely the corpses of another world. But to understand how a collision billions of years ago is actively shutting down our magnetic shield today, we have to look at the momentum of the core itself, because the data shows that the core is not just slowing down, it is wobbling, and the cause of that wobble brings us to a terrifying realization about the true nature of these hidden giants. The anomaly we found in the shear wave velocity was just the surface of the problem. When we isolate the angular momentum of the core, we see a drag factor that cannot be explained by fluid dynamics alone. Something is physically gripping the core. To understand the mechanics of this planetary break and to verify the origin of these massive structures, we have to simulate the most violent day in Earth's history. The evidence suggests that the entity sabotaging our magnetic field is a visitor that arrived 4 billion years ago, and it never left. To understand how a planet buried 4,000 miles beneath us is physically gripping the core, we must stop thinking of the Core-Mantle Boundary as a smooth, polished interface. For decades, the standard geological model depicted the boundary between the rock of the mantle and the metal of the core as if it were a ball bearing spinning inside a greased socket. That model is wrong. The new seismic resolution has revealed that the underside of these massive blobs is not flat. It is rugged. It creates what we call topography on the core-mantle boundary. Imagine mountains, valleys, and jagged ridges, but inverted, hanging down from the ceiling of the underworld into the molten ocean of the outer core. These inverted mountain ranges, formed by the heavy, distinct material of the blobs, create physical friction. As the liquid iron of the outer core rushes past these solidified obstacles, it drags, it catches, it creates a coupling force that transfers angular momentum between the fluid core and the solid mantle. This is the mechanical break. We can actually measure the effectiveness of this break by looking at the rotation of our planet. We know that the length of a day on Earth is not constant. It fluctuates by milliseconds over decades. When we overlay the fluctuations in the length of a day with the magnetic jerks caused by turbulence in the core, the patterns match perfectly. When the blobs drag heavily on the core slows down. To conserve the total angular momentum of the planet, the mantle and the crust must speed up, making our days slightly shorter. Conversely, when the coupling loosens, the core speeds up and the crust slows down, lengthening our days. These massive structures are actively controlling the spin rate of the ground you are standing on. But physical friction is only the clumsy part of the mechanism. The more elegant and terrifying braking system is electromagnetic. We now suspect that the base of the African and Pacific blobs is highly conductive. Because they are rich in iron oxide, much more so than the surrounding mantle, they act like electrical wires. The outer core is a moving conductor. The blobs are stationary conductors. When you move a conductor past a magnetic field, you generate an electric current. This is the basic principle of a generator. But there is a counterforce known as the Lorentz force. The electrical currents generated by the interaction between the core and the conductive blobs create a magnetic field that pushes back against the motion of the core. This is electromagnetic drag. It is the same force that slows down a roller coaster using magnetic brakes. The African blob is essentially a giant magnetic brake pad, generating a counterforce that fights the rotation of the fluid iron. This explains why the magnetic field is collapsing so rapidly in the South Atlantic. The iron currents are not just being diverted, they are being electromagnetically decelerated. The dynamo is losing power in this specific sector because the energy that should go into generating the magnetic field is being lost as heat and electrical resistance at the base of the blob. We are witnessing a short circuit in the planetary engine. But identifying the mechanism of the damage only forces us to confront the deeper, more unsettling question of the object itself. Why is this material here? Why is it so conductive? And why is it so incredibly dense? Standard planetary evolution cannot account for it. In a cooling magma ocean, the heavy elements sink to the center to form the core, and the lighter silicates float to form the mantle. This separation should be absolute. To find large, continent-sized clumps of heavy, iron-rich material floating in the middle of the mantle is like finding whole bricks floating halfway down a glass of milk. It violates the laws of buoyancy unless those bricks were introduced from the outside after the Earth had already formed. This brings us to the impact simulation data. We have known for a long time that the Earth likely collided with a protoplanet the size of Mars roughly 4.5 billion years ago. We call this lost world Theia. The standard theory was that Theia struck the Earth with a glancing blow, vaporizing the upper layers of both worlds and throwing a ring of debris into orbit that eventually coalesced to form the Moon. In this scenario, the core of Theia merged with Earth's core, and the rest of Theia was mixed homogeneously into the Earth's mantle, leaving no distinct trace. However, new supercomputer simulations, running at resolutions millions of times higher than previous models, have shattered this assumption. The new data suggests that the impact was not a glancing blow, but a near head-on collision at a 45-degree angle. More importantly, the simulation modeled the density of Theia's mantle. It turns out that Theia was likely an older, denser world than the proto-Earth. When this dense projectile struck our planet, it did not splash harmlessly. It penetrated. The simulations show the mantle of Theia punching through the Earth's crust and upper mantle like a bullet through ballistic gel. Because Theia's material was roughly 2 to 3% denser than Earth's mantle, it did not mix. It clumped together. It maintained its structural integrity as it sank. Visualize two massive fragments of an alien world, roughly the size of our moon, plunging through the magma ocean of the early Earth. They sank thousands of kilometers down until they hit the hard boundary of Earth's core. There, they stopped. They flattened out. They settled into the massive piles we see today. The African blob and the Pacific blob are not geological tumors. They are the physical remains of Theia. We are not living on a single planet. We are living on a graveyard where the corpse of a second planet lies buried around the core of the first. This hypothesis was controversial until we found the chemical fingerprint. If these blobs are truly alien fragments, their chemical composition should differ from the rest of the Earth. We cannot drill to the Core-Mantle Boundary, but the Earth sometimes brings samples to us. Hot plumes of rock, known as mantle plumes, rise from the edges of these blobs, punching through the crust to form volcanic islands like Hawaii, Iceland, and Samoa. When geochemists analyze the lava from these deep source volcanoes, they find something impossible. They find isotopes of noble gases, specifically helium-3 and neon-22, in ratios that do not match the rest of the Earth's mantle. These isotopes are primordial. They date back to the time before the Earth had an atmosphere. In the rest of the mantle, these gases have long since escaped or been diluted by plate tectonics, but inside the blobs, they have been preserved in a time capsule. The ratio of these isotopes matches the theoretical composition of Theia. Even more striking, the isotopic signature of the blobs bears a haunting resemblance to the isotopic signature of lunar rocks brought back by the Apollo missions. This is the smoking gun. The moon is made of the debris that was thrown outward. The blobs are made of the debris that sank inward. They are siblings. The structure distorting our magnetic field under Africa is the dark twin of the moon lighting up our night sky. Before we move to the next critical piece of evidence, if you are finding this connection between the deep Earth and the moon fascinating, leave a comment below with your thoughts on the Theia impact, as we want to know how this reshaping of planetary history changes your perspective on the ground beneath your feet. This realization redefines our understanding of the Earth's interior. We are not standing on a solid, static rock. We are standing on a dynamic system where two worlds are still interacting. The blobs are not dead rock. They are evolving. The heat from the core is slowly baking them, and they are reacting. The density difference that kept them separate for billions of years is keeping them intact, but the convection currents of Earth's mantle are constantly trying to erode them. This struggle between the Earth's mantle and the alien blobs creates the massive plumes we see today, but it also creates something else: instability. The edges of the blobs are fraying. We are detecting smaller structures broken off from the main bodies, drifting through the mantle. These rogue fragments are carrying their distinct chemistry and their thermal insulating properties into new regions of the Core-Mantle Boundary. If a large fragment of the African blob were to break off and drift under the North Atlantic, it would begin to insulate a new section of the core. It would disrupt the magnetic field generation in a new location. We are seeing evidence that this has happened before. When we look at the paleomagnetic record, the history of the magnetic field frozen into ancient rocks, we see periods of extreme chaos. We see times when the magnetic poles flipped back and forth rapidly, or when the field collapsed to 10% of its strength for thousands of years. Previously, these events were thought to be random quirks of the dynamo. Now, we must consider the possibility that they are caused by landslides in the deep Earth. A collapse of the heavy Theia material would send shock waves through the core, disrupting the flow of iron instantaneously. It would be a geological stroke. The connection between the blobs and the core's fluid dynamics is becoming clearer, but the implications are becoming darker. We know the blobs are breaking the core. We know they are weakening the field. We know they are alien in origin. But the most alarming correlation is not with the magnetic field alone. It is with the biosphere. When we map the positions of these blobs against the surface of the Earth and then overlay the locations of the largest volcanic eruptions in history, the large igneous provinces responsible for mass extinctions, we see a near-perfect alignment. The Great Dying, the extinction event that wiped out 90% of life on Earth 250 million years ago, was caused by the Siberian Traps eruptions. The magma source for that eruption traces directly back to the edge of the LLSVPs. The extinction of the dinosaurs, accelerated by the Deccan Traps volcanism in India, also traces back to a plume rising from these structures. It seems that every time these alien fragments burp, life on the surface dies. They are not just passive obstacles messing with our compasses. They are active engines of destruction that operate on a cycle we are only just beginning to comprehend. The mechanism is terrifyingly simple. Because the blobs are hotter than the surrounding mantle, they act as launching pads for superheated plumes. These plumes rise rapidly, carrying vast amounts of heat and volcanic gases. When they hit the crust, they burn through, releasing millions of cubic kilometers of lava and enough carbon dioxide and sulfur to poison the atmosphere for millennia. But the magnetic weakening we are seeing today suggests a different kind of threat. It is not a volcanic winter we need to fear immediately. It is a radiation summer. The South Atlantic anomaly is deepening. The hole in the shield is widening. And as the African blob continues to strangle the convection currents below it, the weakness is spreading. We are entering a period where the Earth's natural defense system is being compromised from the inside out. The very architecture of our planet, the collision that gave us our moon and likely the unique conditions for life, has left a poison pill in the center of the world, a pill that is currently dissolving. As we stare at the satellite data showing the red zone of radiation danger expanding across the Atlantic and creeping toward the American continent, we have to ask, what happens when the anomaly is no longer an anomaly? What happens when the weak spot becomes the global average? The correlation between these deep Earth distortions and the collapse of the magnetic field is leading us toward a potential planetary reset. The data indicates we are on the precipice of an excursion, a temporary collapse of the dipole field. But unlike previous excursions in the geological record, this one is happening to a civilization dependent on electricity, satellites, and fragile silicon chips. To understand the severity of this risk, we have to look at what happens when the cosmic radiation that is currently leaking through the South Atlantic anomaly begins to pour through in earnest. The historical data suggests that when the field weakens to this degree, the climate reacts in ways that models have failed to predict. We are seeing the precursor signals of a radiation rift that could alter the atmospheric chemistry of the planet. When a high-energy cosmic ray slams into the upper atmosphere, it does not simply vanish. It shatters the nitrogen and oxygen atoms it collides with, creating a cascade of secondary particles and a specific chemical byproduct known as nitrogen oxide. Under normal conditions, our magnetic field deflects the vast majority of these incoming particles before they ever reach the stratosphere. But above the South Atlantic, directly over the footprint of the African blob, the shield is thinning so rapidly that this chemical reaction is accelerating. We are witnessing the localized destruction of the ozone layer, not from chlorofluorocarbons or industrial pollution, but from the geophysics of the deep Earth. This is the invisible mechanism that links the continent-sized mountains in the mantle to the air we breathe. As the African large low shear velocity province continues to disrupt the flow of iron in the outer core, the magnetic field lines above it are fraying. This allows high-energy protons from the Sun and deep space to penetrate deeper than they should. When these particles ionize the atmosphere, they strip away the ozone that protects the southern hemisphere from ultraviolet radiation. We have spent decades worrying about the hole in the ozone layer caused by human activity. Yet we are now observing a new, natural hole opening up, driven by the alien architecture buried beneath our feet. The implications of this atmospheric breach extend far beyond a slight increase in UV radiation. We must look at the historical correlation between these magnetic excursions and global climate events. When we analyze the geological record, specifically the Lachamps event 42,000 years ago, we see a terrifying pattern. During this period, the Earth's magnetic field strength plummeted to less than 6% of its current value. The poles drifted wildly, and, crucially, the protective shield against cosmic radiation effectively collapsed. New data from ancient kauri trees preserved in New Zealand swamps shows a massive spike in atmospheric radiocarbon during this exact window. This indicates that the atmosphere was being bombarded by solar particles. But the trees tell us something else. The climate shifted violently. We see evidence of massive electrical storms, changes in wind patterns, and the sudden expansion of ice sheets. The weakened magnetic field allowed the solar wind to strip away the upper layers of the atmosphere, altering the thermal dynamics of the planet. This suggests that the magnetic field is a critical component of our climate system, one that is often ignored in standard models. If the African and Pacific blobs are indeed destabilizing the dynamo to the point of a full excursion or reversal, we are not just looking at a navigational hazard. We are looking at a driver for rapid climate change. The correlation becomes even more disturbing when we look at the extinction of megafauna. The Lachamps event coincides with the disappearance of the Neanderthals and the extinction of the giant Australian megafauna. While correlation does not always equal causation, the biological stress caused by increased ultraviolet B radiation and the collapse of stable weather patterns would have pushed stressed populations over the edge. We are currently watching the South Atlantic anomaly expand westward. It is growing. In the last 5 years, data from the Swarm constellation shows that the anomaly is actually splitting into 2 distinct lobes. This bifurcation suggests that the disturbance in the core is becoming more complex. The braking effect of the African blob is creating multiple eddies in the molten iron, creating a multi-headed hydra of magnetic weakness. As these lobes spread, they cover more of the surface, exposing more of the biosphere to this ionizing radiation. However, the most immediate and quantifiable danger is not to our biology, but to our technology. We have built a civilization that hangs by a thread of silicon and copper. Our entire global economy, our communication networks, and our navigation systems rely on a fleet of satellites orbiting in the low Earth environment. These satellites are designed to operate within the protection of the magnetosphere. But as the South Atlantic anomaly deepens, that protection is vanishing in a key orbital corridor. When a satellite passes through this region, it is subjected to a bombardment of high-energy protons. These particles can strike the sensitive microchips on board, causing what engineers call a single event upset. This is when a bit of data is flipped from a 0 to a 1, or vice versa, by the physical impact of a subatomic particle. This can cause software to crash, guidance systems to lock up, or, in severe cases, it can permanently fry the electronics, turning a billion-dollar piece of infrastructure into a drifting brick. The Hubble Space Telescope frequently has to shut down its sensors when passing through this anomaly to prevent damage. The International Space Station, which orbits through this danger zone, has reported glitches in computers and flashes of light seen by astronauts even when their eyes are closed. These are the result of cosmic rays passing through their retinas. This is the physiological evidence that the shield is failing. As the anomaly expands due to the churning caused by the mantle blobs, the safe zone for low Earth orbit is shrinking. We are facing a future where specific orbits may become unusable. If the field weakens further, the risk of a Kessler syndrome event increases. This is a scenario where a satellite disabled by radiation collides with another, creating a debris field that destroys other satellites in a cascading chain reaction. The invisible hand of the mantle blobs could effectively imprison us on our own planet by destroying the orbital infrastructure we use to look outwards. But the threat on the ground is equally severe. We know that a weakening magnetic field lowers the threshold for solar storms to impact the surface. In 1859, a massive solar flare known as the Carrington event hit the Earth. Telegraph wires burst into flames, and operators received electric shocks. At that time, the magnetic field was stronger than it is today. If a similar solar storm were to hit us now, with the field weakened by the influence of the Theia remnants, the induction currents generated in our power grids would be catastrophic. The interactions between the solar wind and the conductive magma at the Core-Mantle Boundary suggest a coupling that amplifies these effects. The blobs are not just passive obstacles. They modify the frequency at which the Earth resonates with the Sun's magnetic cycles. By slowing the core, they may be tuning our planet to be more receptive to solar energy dumps. A major geomagnetic storm today would melt the copper windings of giant transformers that form the backbone of the electrical grid. These transformers take months or years to replace. We are talking about the potential for a blackout that lasts not for days, but for years. This is the true danger of the hidden giants. They have lowered our defenses right at the moment when our technological dependence is at its highest. The synchronization of the weakening field with the upcoming solar maximum creates a window of vulnerability that is unprecedented in human history. We must also consider the biological navigation systems that are being disrupted. Whales, birds, and sea turtles use the magnetic field to migrate. In recent years, we have seen an unexplained increase in cetacean strandings, particularly in regions bordering the South Atlantic anomaly and the Pacific anomaly. These animals are following magnetic lines that are being twisted by the turbulent iron flow deep below. They are being led into shallow waters, into traps, because the map they have evolved to trust is being rewritten by the geological anomalies in the mantle. This brings us to the final, sweeping realization of what these large, low-shear velocity provinces truly represent. We used to think of the Earth as a finished project, a stable platform for life. But the discovery of these alien structures proves that the Earth is still in the process of becoming. The collision that formed the Moon did not just create a satellite, it injected a foreign agent into the heart of our world. We are living on a hybrid planet. The dynamics we are observing, the slowing of the core, the lengthening of the day, the collapse of the magnetic field, are the symptoms of a planetary metabolism that is struggling to digest this ancient meal. The blobs are vast reserves of heat and chemical potential that are actively warring with the convection of the Earth's mantle. As they release heat, they drive the super plumes that crack the crust. As they insulate the core, they kill the magnetic field. They are the architects of our surface conditions, playing a game that spans billions of years. The science is clear. The magnetic field is not fading due to random chance. It is being strangled. The machinery of the core is being gummed up by the debris of a dead world. And while this process is slow on a geological timescale, it is incredibly fast on a human timescale. The acceleration of the magnetic drift in the last decade is a warning shot. We are now racing to update our magnetic models. The World Magnetic Model, which guides everything from smartphone GPS to military navigation, is having to be updated more frequently than ever before because the field is changing so erratically. We are chasing a moving target. The Earth is rewriting its own rules, and we are just trying to keep up. The investigation into the African and Pacific blobs has moved from theoretical geophysics to urgent planetary defense. Understanding the fluid dynamics around these structures is now as critical as monitoring the weather. We need to know when the next magnetic jerk will happen. We need to know if a piece of the blob has broken off and is drifting towards a new section of the core. We need to map the subsurface weather of the mantle to predict the space weather above. This is a reminder that in the study of the cosmos, there is no separation between the up and the down. The star we orbit and the core we stand upon are linked in a circuit of energy and magnetism. The hidden giants beneath Africa and the Pacific are the switchboards that control this connection. They are the remnants of a cosmic catastrophe that are still shaping our destiny today. If you believe that scientific reporting should dig deeper than the headlines and expose the raw data that defines our reality, hit the like button on this video. It helps the algorithm find other curious minds who want to understand the true machinery of our planet. We have peeled back the crust, looked through the mantle, and found the intruders sitting on the core. The mystery of the South Atlantic anomaly is solved, but the challenge it presents is just beginning. As the Earth continues its 4 billion year struggle to reach equilibrium, we will be here, watching the data, measuring the field, and tracking the silent, shifting giants that hold our magnetic future in their hands.